Hello, welcome back. Today we are going to focus on solving linear systems using the elimination method, but this time we'll need to multiply to get the same coefficient number before we can eliminate. Go ahead and take a minute to fill in your table of contents. Okay, so looking here, what we have is we have another system set up in standard form. That's when we want to use this method. However, previously we've already had the same coefficient numbers of one of our variables that we could eliminate. Now we need to create that same coefficient with opposite signs. We do that by multiplying one of the terms to another. So for instance, I want to see which one's going to be a factor of the other one. If I look at my x variable here, I can see that 2 is a factor of 4. So that means I can multiply this entire equation by 2 to be able to get that eliminated. So for instance, I would say 2 times 2 would give me that 4x. And now you can see I've got a negative 4 and a positive 4, so that will eliminate. Well, in order to keep these equations equivalent, I need to multiply that 2 to every term in the equation. So this would become 6y equals 24. Now I have what I need to eliminate, and the rest is exactly the same as the last lesson. So we add it up. Negative 4 plus 4 gives us that 0, so my x is eliminated. 5 plus 6 is 11y. Negative 2 plus 24 is 22. And then we're going to solve for y. So I'm going to divide by 11. So we found our y value to be 2. We still need to find x, so we're going to substitute it back into one of the original equations. I always like to use the one that is all positive numbers or all smaller numbers. So I'm going to use the first one. So I've got 2x plus 3, and I need to substitute that y value in for y and solve for x now. So I'm going to get 2x plus 6 equals 12. Subtract 6 on both sides. 2x equals 6, so x is going to be 3. Remember, you must write your answer as a coordinate. So our coordinate is 3, 2. And we can check our answer by plugging those back in. So 2 times 3 is 6, 3 times 2 is 6, 6 plus 6 is 12, so it works for the first one. Negative 4 times 3 is negative 12. 5 times 2 is 10. Negative 12 plus 10 is negative 2. So we know that that will check out. Let's take a look at another example. Okay, so here you can see they're both in standard form again. And remember, if you struggle, go ahead and write that invisible 1 in front of the y. So if we're looking at the y values here, I could see that 1 is a factor of 4. But also notice I have no negative. So when I'm going to multiply this one, I'm going to multiply this equation by a negative 4. Because remember, I need to get those opposite signs. So negative 4 times 3 is negative 12x. Negative 4 times 1 is going to give me a negative 4y. And then negative 4 times 3 is negative 12. So I distribute it to all three terms. I'm going to go ahead and bring down that first equation so my equations are directly underneath each other. And now we can go ahead and add them using the elimination method. So my y's will cancel this time. Negative 12 plus 2 would give me a negative 10x. Negative 12 plus negative 18 will give me a negative 30. And then we divide by negative 10. Do not forget to do the division of the negative, so that's going to make this a positive 3. So we found our x value. We need to go back and find the y. Again, I'm going to use that equation with less negatives or smaller numbers. So I'm going to use 3x plus y equals 3. So I'm going to substitute 3 in for x and solve for y. So 3 times 3 is 9. We're going to subtract 9 on both sides. So y is going to be a negative 6. And then you must write your answer as a coordinate. So 3, negative 6. Again, it's always a good idea to check your answer. So I'm going to just kind of do that. 2 times 3 is 6. 4 times negative 6 is a negative 24. So 6 plus negative 24 is negative 18. So it works for the first equation. 3 times 3 is 9. Plus negative 6 is 3. So we know that that'll work for both equations. Okay, so hopefully here we can recognize that in front of x we've got the same coefficient number, but I don't have a negative. So here that means I'm going to need to multiply by a negative 1. And it doesn't matter which equation you want to do because it would be the same for either or. So if you choose the second one, that's fine. The first one, it's still going to work. We're going to multiply it by a negative 1. So I'm going to get a negative 5x plus 7y equals negative 9. Some like to choose the one with smaller numbers, which would be the second equation. Either or, it doesn't matter. So now we're going to go ahead and eliminate our x's because that would be 0. Negative 3 plus 7 is 4y. And 1 plus negative 9 is negative 8. So now we divide by 4. So y will be negative 2. I'm going to use that second equation to find my x value. So 5x minus 3y equals 1. And I'm going to substitute negative 2 in for y. So I've got 5x minus 3 times negative 2 equals 1. Here's that negative times a negative, so this is going to become a positive 6. And then I'm going to subtract 6 on both sides. Divide by 5, so we get x is negative 1. So our coordinate would be negative 1, negative 2. Okay, and then we check our answer. 5 times negative 1 is negative 5. Negative 7 times negative 2 is a positive 14. So negative 5 plus 14 is 9. 5 times negative 1 is negative 5. Negative 3 times negative 2 is a positive 6. So negative 5 plus 6 is a positive 1. So we can see that that will check out. Notice I'm not doing a whole lot. I'm just plugging those numbers in for the x and the y's just to see if they'll work in that equation. Just a little mental math to show that I've solved it correctly. As you look at this next example, you're probably going to notice that none of the numbers are a factor of the other. 3 is not a factor of 4, 4 is not a factor of 5. So here's where it tends to get a little bit more difficult because we need to multiply both equations. What we want to choose are the smaller numbers. So I'm going to choose 3 and 4, and I need to multiply them to where 1 is going to be negative and 1 will be a positive. So you want to think of your least common multiple. So our least common multiple between 3 and 4 is 12. So I'm going to multiply the first equation by a negative 4. Or a positive 4. It doesn't matter. So if we chose a positive 4, we're going to get 12x minus 16y equals 24. But if we choose to multiply it by a positive 4 on the first one, that means the negative needs to be the second number. So now I'm going to multiply the second equation by negative 3. So that's going to give me a negative 12x plus 15y equals a negative 21. So either or, it doesn't really matter, but you want to make sure you're multiplying to get the least common factor. It'll make it a little bit easier for you, and if you choose the smaller coefficient numbers, that will also help make it a little easier. Now we have what we need to solve this by elimination. The x's are eliminated. We're going to end up with a negative 1y. Negative 16 plus 15 is negative 1. And 24 plus a negative 21, or 24 minus 21, is 3. So y would be a negative 3, because we divide by that negative 1. So now we still need to find our x value. I'm going to use the first equation because it has smaller numbers. So 3x minus 4y equals 6. I'm going to plug in that negative 3. So 3x minus 4 times negative 3 equals 6. So negative 4 times negative 3, double negative there, so that's going to turn it to a positive. We subtract 12 on both sides. We get a negative 6. So x is going to be negative 2, because negative 6 divided by 3 is negative 2. So our coordinate here is negative 2, comma, negative 3. Make sure you are writing it x and then y. All right, as we look at this next example, again, you'll see I have no factors of the other. 9 and 7 are not factors of each other, and 3 and 2 are not factors of each other. So I want to, again, use my smaller coefficients here when I need to create the least common multiple between them. 1 is negative, so I don't need to worry about multiplying by a negative, but I do need to get them the same. So my least common multiple between 3 and 2 is 6. So I'm going to multiply the first equation by 2 and the second equation by 3. So 2 times 9 gives me 18x. 2 times negative 3 gives me a negative 6y. And 2 times 12 gives me 24. 3 times 7 is 21. 3 times 2 is 6. And then 3 times 5 is 15. Now I have what I need to eliminate. So my y's have the same coefficient number but opposite signs. So they will be eliminated. And then I add everything else. So 18 plus 21 is 39. (24 plus 15 is 39. Divide 39 by 39, so x is 1. I still need to find y. So I'm going to use the second equation to find y here because it has smaller numbers. So I've got 7x plus 2y equals 5. So I'm going to do 7 times 1 plus 2y equals 5. 7 plus 2y equals 5. Subtract 7 on both sides. Five minus 7 is negative 2. Negative 2 divided by 2 is a negative 1. So our coordinate here is 1 and negative 1. Okay, so when we look here, you should recognize that we could potentially multiply by two numbers. Both in front of the x and y are those imaginary ones. So x is a -1 and y is a +1. And we see that both the coefficients are opposite signs. So to choose which one to multiply by, I, again, always choose the smaller number. So here I'm going to look at the y. My y is a 2. So I'm going to multiply the second equation by 2. So I'm going to get -2x plus 2y equals 2. And then I'm going to bring down that first equation. 3x minus 2y equals 3. Using the smaller coefficients to work with will just make it easier for you. So now I can eliminate my y values. -2 plus 3 is going to give me 1x, and 2 plus 3 is 5. So x is 5. Now I'm going to go back to that original equation with the smaller numbers. So that's a -x plus y equals 1. So when this happens, we still plug in 5. That negative stays there, though. So it's going to become a -5 plus y equals 1. So I'm adding 5 on both sides. So y becomes 6. So my coordinate here is 5, 6. Okay, so when we're looking at this next example, we should recognize 5 is a factor of 10. So I want to eliminate my y's, but my signs are both positive. So I'm going to need to multiply that first equation by a -2 to get me a -10. So I'm going to get -4x minus 10y. So now I have what I need to eliminate, and a -6 on the other side, because -2 times 3 is -6. So I'm going to eliminate these y's. So 3 plus a -4 is a -1x. -3 plus -6 is -9. So x will be a +9, because -9 divided by -1 is a positive. Now we still need to find y. So I'm going to take the first equation because that has smaller numbers. So 2x plus 5y equals 3. So I'm going to do 2 times 9 because we just found x to be 9 plus 5y equals 3. So it's going to be 18 plus 5y equals 3. Subtract 18 on both sides. So 5y is going to equal -15. So y would be -3 because -15 divided by 5 is -3. So our coordinate here is 9, -3. Remember, that's the coordinate where these lines would intersect on a graph. That's what that means. All right, so when we look at this next example, we're going to notice again that we do not have factors of the other. So we need to figure out what we're going to use to multiply. Again, I like to choose the smaller numbers, but 5 and 2 would create 10, and that is technically a smaller number than 12, which is the 4 and the 3. But notice that we've already got a positive and a negative with those coefficients in front of x. So that would be where I would start, and I would multiply the first equation by 3 and the second equation by 4 to get the same coefficient. So I'm going to have 12x plus 15y, and then we need to do 3 times 35. You might need your calculator for that, or maybe show a little work, because now we've got a larger number. But that's going to be 105. Now we're going to get -12x plus 8y equals negative 36. So we should see that we're going to eliminate the x value, and then we're going to add 15 plus 8, which would give us 30y, and then 105 plus a negative 36. That's not 30. That is 23. I don't know why I did that. And then 105 plus negative 36 is 69. Now we're going to divide 69 by 23. So y would be 3. All right, so now we still need to find x. So here, again, I like to use the one with the smaller numbers or less negatives. So if negatives is something that really messes you up, you would want to use the first equation because there's no negatives there. I still like to use the one with just the smaller numbers, and I'm pretty good with the negatives, so I'm going to use the second equation. So we're going to get negative 3x plus 2 times 3 equals negative 9. Negative 3x plus 6 equals negative 9. I'm going to subtract 6 on both sides. So that's going to give me a negative 15. Negative 15 divided by negative 3 is going to turn this into a positive 5. So our coordinate here is 5, 3. Hopefully at this time you're starting to get the pattern and be able to solve these. Now is your time to give it a try. So go ahead and pause this video at this time and try these next 2 problems. Hopefully you've taken the time to pause the video and you tried to work out these 2 problems. Let's see how you did. Okay, so you should have gotten 4, negative 6 for the first one and negative 9, 2 for the second one. Remember to make sure you are writing down any questions you might have as you're going through this video, so when you come to class you can ask me. And in summary, it's a good idea to pause the video and write this down, but we want to make sure both equations are in standard form. If necessary, multiply one or both of the equations by an integer, so one of the variables will be eliminated. Add the columns. Remember, that's like combining like terms. Solve the equation for the variable that remains, and then substitute the variable from step 4 into the other equation to solve for the other variable. Always remember to write your answer as a coordinate.